me as we explore the world of numbers full of fun and excitement. I am your teacher, Loreto, your virtual teacher for today's lesson. Be ready your self-learning module, your pen and paper, as well as your scientific calculator with you, and let us have a wonderful day of learning. Look at the pictures on the screen. We have a biscuits, playground monkey bars, grass bridge, and hammer. What do you notice? Can you see the triangular patterns? Do the triangles you see in the pictures contain a right angle? Excellent class. The triangles that we see in the pictures are known as oblique triangles. An oblique triangle is a triangle which do not contain any right angle. Oblique triangles may be classified into two, acute and obtuse. An acute triangle is a triangle whose angles are all less than 90 degrees, like this one. An obtuse triangle is a triangle in which one of the angles is more than 90 degrees, like this one. To solve oblique triangles, we will use the law of sines and the law of cosines. In today's video, we will discuss the law of sines. Law of sines is the sine of an angle of a triangle divided by its opposite side is equal to the sine of any other angle divided by its opposite side. For any triangle ABC in which A, B, and C are the lengths of the sides opposite the angles with measures A, B, and C respectively. The formula we're going to use is sine angle A over its opposite side A is equal to sine angle B over its opposite side B is equal to sine angle C over its opposite side C. Or A is equal to sine A is equal to B over sine B is equal to C over sine C. The law of sines is easy to follow and very useful in solving oblique triangles when you know the following information. Two angles in one side, SAA case and ASA case. Two sides and an angle opposite one of these sides, SSA case.
Let us have an example. Find the missing parts of triangle ABC. Here's the figure. Given, the measure of angle A is 70 degrees. The measure of angle B is 80 degrees. And the length of segment BC or side A is 12. Let's find the measure of angle C, segment AC or side B, segment AB or side C. This is a SAA case, so we use the law of sines.
When two angles of a triangle are given with one side, we first find the third angle. In order for us to solve the measure of angle C, we use the concept that the sum of the interior angle of any triangle is equal to 180 degrees.
So we have measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Substitute the measure of angle A is 70 degrees plus the measure of angle B is 80 degrees plus the measure of angle C is equal to 180 degrees. 70 degrees plus 80 degrees is equal to 150 degrees plus the measure of angle C is equal to 180 degrees. We use the transposition, so we have measure of angle C is equal to 180 degrees minus 150 degrees. Therefore, the measure of angle C is 30 degrees.
Now, let us solve the other two sides using the law of sines. Let's solve for the length of the segment AC or the side B. The formula to solve B, we have sine angle A over A is equal to sine angle B over B. Substitute the given values, we have sine 70 degrees over 12 is equal to sine 80 degrees over B. Cross multiply, we have 12 times sine 80 degrees is equal to B times sine 70 degrees. Divide both sides of the equation by sine 70 degrees. So we have B is equal to 12 times sine 80 degrees over sine 70 degrees. Compute using your scientific calculator. We have B is equal to 12.57. Therefore, the length of the side B is 12.57. Now, let us solve for the length of the segment AB or side C. The formula we're going to use is sine angle A over A is equal to sine angle C over C. Substitute the given values, we have sine 70 degrees over 12 is equal to sine 30 degrees over C. Cross multiply, we have 12 times sine 30 degrees is equal to C times sine 70 degrees. Divide both sides of the equation by sine 70 degrees. We have C is equal to 12 times sine 30 degrees over sine 70 degrees. Compute using your scientific calculator, we have C is equal to 6.39. Therefore, the length of the side C is 6.39. Now, let's go back to the figure and complete the missing parts.
The measure of angle C is 30 degrees. The length of side B is 12.57 and the length of side C is 6.39.
Let us have another example. Find the missing parts of triangle ABC. Given that the measure of angle A is equal to 63 degrees, the measure of angle B is equal to 49 degrees, and the length of segment AB or side B is equal to 78. Find what is the measure of angle C, the length of segment AC or side B, and the length of segment BC or side A. So this is an example of ASA case, therefore we're going to use the law of sines. Since the measure of two angles of the triangle are known, the measure of the third angle can be determined using the concept that the sum of the measures of the angles of a triangle is 180 degrees. So we have the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. Substitute, the measure of angle A is 63 degrees and the measure of angle B is 49 degrees plus the measure of angle C is equal to 180 degrees. Add 63 degrees and 49 degrees, so we have 112 degrees plus the measure of angle C is equal to 180 degrees. We use the transposition, so we have the measure of angle C is equal to 180 degrees minus 112 degrees. Therefore, the measure of angle C is equal to 68 degrees. Now, let us solve for the length of the segment AC or side B. First, set up the law of sines to solve for B. We're going to find the formula to solve for B. So the formula is sine angle B over B is equal to sine angle C over C. Substitute the given values. So we have sine 49 degrees over b is equal to sine 68 degrees over 78. Cross multiply. So we have 78 times sine 49 degrees is equal to b times sine 68 degrees. Divide both sides of the equation by sine 68 degrees. So we have b is equal to 78 times sine 49 degrees over sine 68 degrees. Compute using a scientific calculator. So we have b is equal to 63.49. Therefore, the length of side b is 63.49. Next, let us solve for the length of the segment BC or side A. First, let us set up the law of sines to solve for A. So the formula we're going to use to solve for A is sine angle A over A is equal to sine angle C over C. Substitute the given values. So we have sine 63 degrees over A is equal to sine 68 degrees over 78. Cross multiply. So we have 78 times sine 63 degrees is equal to A times sine 68 degrees. Divide both sides of the equation by sine 68 degrees. So we have A is equal to 78 times sine 63 degrees over sine 68 degrees. Compute using your scientific calculator. So we have A is equal to 74.96. Therefore, the length of side A is 74.96. Now, let's go back to the figure and complete the missing parts. The measure of angle C is 68 degrees. The length of side B is 63.49. And the length of side A is 74.96. Now, let's have a practice exercise. Calculate the measure of each missing angle and the length of each missing side of the given triangle using the law of sines. Your timer starts now. Let's check. The measure of angle B is 45 degrees. The length of side A is 31.21. And the length of side B is 22.15.
Did you get the correct answers? Great! With that, I hope you learned something in that activity. Let us sum up today's lesson in solving oblique triangles using the law of sines. We use the formula sine angle A over A is equal to sine angle B over B is equal to sine angle C over C. Or we have A over sine angle A is equal to B over sine angle B is equal to C over sine angle C. When two angles of a triangle are given with one side, we first find the third angle and then use the law of sines to find the other two sides.
Now, it's your turn. Prepare your pen and paper for your solutions. Are you ready? You may now start.
Here is your assignment.
Congratulations, grade 9 learners, for a job well done. I hope you've learned a lot from this video. See you next time in another enjoyable episode of Exploring the Fun World of Numbers. This is your teacher, Loreto. Thank you and have a great day.